Good morning students. In today's video, we'll continue the exercise 2.5. In the 13th problem, D and E are points on the sides CA and BC respectively of the triangle ABC, and a ABCD, it is a right angle triangle at C. Prove that AE square plus BD square is equals to AB square plus DE square. We need to show that, right? According to this equation, which all triangles we have to consider? Let us see that. Here AE means what? AE means this is the hypotenuse of the triangle ACE, isn't it? And one more, BD means what? B and D means this is the hypotenuse of the triangle BCD. And AB is the hypotenuse of the triangle ACB, isn't it? And DE means this triangle we need to consider here. Here we got 4 triangles, right? For those 4 triangles we need to apply the Pythagoras theorem, right? Let's apply the Pythagoras and see. First here I will consider the triangle ACE, this triangle ACE, this triangle, and one more triangle BCD, this triangle I am going to consider. For these 2 triangles we will apply the Pythagoras theorem, right? Using Pythagoras theorem, then hypotenuse of the triangle ACE is AE square equals to AC square plus EC square, isn't it? Then one more is, we'll call this as equation 1, and here we have taken the triangle that is BCD. Then hypotenuse of this triangle is BD square is equals to BC square plus DC square. We'll call this as equation 2. We'll add 1 and 2 here. Add 1 and 2. AE square plus BD square is equals to, AE means what here? AC square plus EC square plus BC square plus DC square, right? Now you can see the right hand side equation, that is. Good morning students. In today's video we will continue exercise 2.5. 13th question, that is, D and E are the points on the side CA and CB respectively of the triangle ABC. It is right angled at a C. We need to show that AE square plus BD square is equals to AB square plus DE square. We need to show that. To show this, here I am going to consider the triangles. You can see according to this equation I am going to consider the triangles here. AE means what? AE means this is the hypotenuse of the triangle ACE, isn't it? So we will consider the triangle ACE. And one more, they have given BD side, BD, right? BD is the hypotenuse of the triangle BCD. And AB is the hypotenuse of the triangle BCA, yes. And DE means we have to consider the triangle ECD. So we have to take here 4 triangles to prove this equation, right? Here for those 4 triangles I am going to use the Pythagoras theorem to prove this equation here. So let's begin with the proof. Solution. First we'll consider the triangle. In triangle ACE and triangle BCD means ACE, this triangle, and one more triangle that is BCD, this triangle I am going to consider. For these 2 triangles we'll use the Pythagoras theorem. Using Pythagoras theorem, right, what we'll get? For the triangle ACE will get AE square plus EC square, AE square is equals to EC square plus then AC square, right? So we'll call this as equation 1. Similarly for the triangle BCD, hypotenuse is BD square is equals to BCD, right? So BC square plus DC square. So we'll call this as equation 2 now. Now again we'll consider two more triangles here. Those two triangles are in triangle. First we are going to consider the triangle ABC will consider. In triangle ABC and triangle we are going to take here ECD, right? ECD. Again for these two triangles we'll apply the Pythagoras theorem. Using Pythagoras theorem, AB is equals to what? AB square is equals to BC square plus AC square. We'll call this as 3, and triangle DE square is equals to EC square plus DC square, right? We'll call this as equation 4. Now we'll add equation 1 and 2. These two equation will add equation 1 and 2 will get AE square plus BD square is equals to EC square plus AC square plus BC square plus DC square, right? You can observe that right hand side of this equation, we'll call this as equation 5. Right hand side of the equation 5 we are getting here EC square plus AC square plus BC square plus DC square, right? Here I am going to substitute AC plus BC. AC plus BC means what here? We are getting here AB or no? Yes, I am going to replace this by AB now. And EC plus DC means we are getting here DE, right? So instead of EC square plus DC square, I will write this. First we'll substitute this equation, we'll get AB square and plus we'll get DE square. So left hand side is AE square plus BD square. Hence we got the required answer. You can observe here AE square plus BD square is equals to AB square plus DE square. Isn't it? We got the same thing or no? This completes 13th proof. Let's move for the 14th one. Okay, 14th question. The perpendicular from A on the side BC of a triangle ABC intersect BC at the D such that DB equals to 3 times of CD. We need to show that 2 times of AB square is equals to 2 times of AC square plus BC square. We need to show here. Here they have given a triangle ABC. For this triangle, from the point A, they have drawn one perpendicular line to the side BC here, right? And also they have given us DB. This DB is equals to 3 times of CD. CD they have given, means here DB means is equals to, or we can write it as, okay, first we'll show it here. What all they have given? DB is equals to 3 times of CD they have given. Here we need to show this, isn't it? Now, to prove this condition, here I am going to considering the two triangles. Those two triangles are triangle ADC and one more triangle is triangle ADB, right? For these two triangles, we'll apply the Pythagoras theorem. We'll obtain two equation there. Let's apply the Pythagoras theorem. In triangle ADC, we can see that AC square is equals to what? CD square plus AD square. And I will keep this AD here only. I will bring this CD to the left hand side. We'll get AC square minus CD square is equals to AD square. We'll call this as equation 1. Similarly, we'll apply the triangle for triangle ADB. In triangle ADB. Again Pythagoras theorem means AB square is equals to AD square plus DB square. We'll apply the same here. Here I will going to keep the AD as it is. We'll bring this DB to the left hand side. We'll get AB square minus DB square is equals to AD square. You can observe that from equation 1 and 2, the right hand side are equal here. So will left hand side will be also equal here, right? I am going to write from 1 and 2, AC square minus CD square is equals to AB square minus DB square. Yes, here I am going to replace this CD square. How to replace this CD square means, you know that CB or BC is equals to what? CD plus DB, right? So we'll write it here. BC is equals to what? CD plus DB, isn't it? Here we can see that in the given thing, DB is equals to 3 times of CD. Here I am going to replace that DB equals to 3 times of CD, right? How to write means CD plus 3 times of CD. So we got here 4 times of CD. This is BC. And we'll keep this CD as it is and BC divided by 4. So we are going to substitute this CD equals to BC divided by 4 in this equation. We'll call this as equation 3, right? Equation 3 becomes AC square minus BC divided by 4 and square, this square, right, is equals to AB square minus, here we got the DB, right? DB means what here we got, that is 3 times of CD, right? We replace it here, 3 times of CD, and this is whole square. Now AC square minus BC square divided by 4 fours are 16 is equals to AB square minus 9 CD square. 3 3s are 9 into CD square. Now we'll take the LCM. We'll get 16 times of AC square minus BC square. So the LCM will be 16 here. That is equals to AB square minus 9 times of CD square. And again we'll instead of CD we are going to substitute this value here, right? So we'll get 16 times of AC square minus BC square divided by 16 is equals to AB square minus CD means what here? That is BC divided by 4 and whole square, right? Now here it is a divide, so we'll multiply 16 for the right hand side here. 16 AC square minus BC square is equals to 16 times of AB square minus 16 into 9. We'll get BC square whole divided by 4 fours will get, that is 16, right? Now this 16, this is get cancels. We'll write 16 times of AC square minus BC square is equals to 16 times of AB square minus 9 into BC square. We can see that this 9 BC square and this minus BC square will bring that to the left hand side. After cancelling we will get plus, or okay, we'll make all the like terms one side here, so that is equals to 16 AB square. Here it is 9BC square. We'll bring this BC to the left hand side. It will be plus BC square. Right. Now from this we'll rewrite it here. 16AC square is equals to 16AB square. And here this is a unlike sign, so we'll subtract it. We'll get 8 times of BC square, isn't it? Now we'll take the common, that is 8. After taking 8, here it is remaining 8 2s are 16 AB square minus BC square. This 16 AC square will keep it as it is. This 8 and 16 will get cancelled. 8 2s are 16, it is here. So 2 times of AC square is equals to 2 times of AB square minus BC square. But here we need 2 times of AB square equals to 2 times of AC square plus BC square, right? So we'll rearrange this equation. We'll keep this 2AB as it is and we'll bring this to the left hand side. So we'll get 2 times of AC square plus BC square. This is the what required proof, right? Hence we proved 14th one. Next we'll move for the 15th. 15th question. In an equilateral triangle ABC, D is the point on the side BC. There is the point D on the side BC, right? Such that DB is equals to 1 by 3 of 3 times of BC. It is there. We should prove that 9 times of AD. AD means we need to join this, right? We'll join this. 9 times of AD square is equals to 7 times of AB square we need to show. Here let's write the given things. ABC is an equilateral triangle, right? So we can say that AB is equals to BC is equals to AC. And I'm going to take this side as a small a. These all are what? Small a, right? From here to here it is also a only. And D is the point on the side BC. Here I have made one construction that I have drawn an altitude from the point A to the BC, which will be the perpendicular. I am making an angle of 90 degrees. And you all know that a line, the altitude of an equilateral triangle, it always divides the third side in 2 equal parts, isn't it? If BC is A means, then BE will be half S on A by 2 and EC will be also what? A by 2, isn't it? So now here I have made a construction. We need to show that 9 times of AD square equals to 7 times of AB square. So let's begin the proof here. In equilateral triangle AB is equals to BC is equals to CA, which is equals to small a, right? And also we know that AE is perpendicular to BC. This is what? Construction. Then we can say that BE will be what? Half means A by 2, right? And if BE is A by 2 means again BD will be what? Again half of A by 2, isn't it? So here we want BD, right? BD is equals to what? Half of BE. We'll write this half as it is. BE means what here? Again, here we don't want to take this. Here they have already given, right? Or they have given DB is equals to 1 by 3rd of BC. We'll write it here also. And BD is equals to what? 1 by 3 times of BC, right? We'll use this only now. So here BD is equals to 1 by 3 times of BC. This is what? This is also given. Now we know that BC is what here? that BC is what here? A or no? BC is what? A. So we'll replace it. BC is A here. So we can write it as A by 3. We got BD is equals to A by 3. Here we need to show that 9 times of AD is equals to 7 times of AB, right? So here I am going to considering only this part. For that, here we got BD here. Next we need to get DE. For that, you all know that we want DE, right? In BE I am going to minus BD. So we'll get DE here. In BE we'll minus BD. BE means what? Here we got it. That is A by 2. We'll mark it. And BD means A by 3, right? A by 3 will write. After taking LCM, we are getting here 3A minus 2A, which is equals to again A by 6. So we got DE as A by 6 here. Next we'll apply the Pythagoras theorem for this right angle triangle, that is triangle AEB, right? Sorry, AED. In triangle AED, we can say that AD square, this is D. AD square is equals to DE square plus AE square, right? Now you can say that here in triangle AEB we know the side AB and even we know the side BE, right? But we don't know the AE. We need to find here AE. How to find AE? That is AE square is equals to AB square minus BE square, isn't it? AB means here we know that is A square minus BE means A by 2. So we get here 2 times of A square minus A divided by 2. 2 minus, okay, sorry, this is square, right? A square, and this will be 4, and this will be also 4 here. Now 4A square minus A square means we'll get 3A square divided by 4. Now we got AE square as what? This much. We'll get AE is equals to A square root 3 divided by 2 will get, isn't it? We got here A. We are going to substitute this value in this equation. So we'll write it here. We know DE, that is A by 6. A by 6 will get whole square plus AE means A root 3 divided by 2. Will keep this AD as it is. Now A square, 6 6 are 36 plus, and this is also whole square. A square square root get cancels, will get the 3 divided by 2 2s are 4. After taking LCM, we'll get LCM will be again 36 only. So A square plus, to make this 36 by, we'll multiply it by 9 here, right? So how much? 9A square and into 3 will get. We'll add them. We'll get 27A square. We'll bring this numerator to the left side. That will be 36AD square, right? Now 36AD square plus equals to 27 plus 1, 28A square. After simplifying, we'll get what? We'll simplify it and see. Then 2 1s are 2, 2 8s are 16. Similarly, 2 1s are 2 4s are 2 9s are 2 7s are. Here we got 9AD square is equals to 7A square. right? Here we want what? AB. Here we want AB square, right? A means what here? AB or BC or CD, right? Here we want AB, so we are going to substitute in place of A value AB. This is AD. 9 times of AD square is equals to 7 times of AB whole square. Hence we proved the problem, right? Next we'll move for the 16th question. 16th question. In an equilateral triangle, prove that 3 times the square of one side is equals to 4 times the square of one of its altitude. Here they have given an equilateral triangle, right? We need to show that one of its sides, means in equilateral triangle all sides will be equal, but here we need to show that one of each square of its side is 3 times equals to the 4 times of its squares of its altitude, right? That is 3a square equals to 4ae square, or you can also write it as 3a means I have taken this side, right? We'll write it as ab square is equals to 4 times of ae square. To prove this, I am going to consider the triangle AAB, or you can also consider the triangle AEC, right? Now you can say that EE angle is making 90 degree, right? So we are going to apply the Pythagoras theorem to prove this. So in triangle AEB, AB square is equals to BE square plus AE square, right? Now you know that in equilateral triangle all sides will be equal, then BC will be also equals to A or not? Yes or no? Now here we have considered the triangle AEB. We want to know BE, right? For that, you know that the altitude of an equilateral triangle, it divides the third side into 2 equal parts, isn't it? So if BC is A means then BE will be A by 2, right? So we are going to substitute these values in the equation, this equation. We don't know AE, we'll keep AE as it is. We'll substitute AB value, that is A square is equals to BE means A by 2 whole square plus AE square. Now we'll bring this A by 2 whole square to the left hand side, so that it will be minus A square by 4, which is equals to AE square. We'll take out the LCM. 4A square minus A square divided by 4 is equals to AE square, right? Now minusing will get 3A square divided by 4 is equals to AE square. We'll bring 4 to the right hand side. 3A square is equals to AE square. Hence we proved, isn't it? You can see that we proved this now. Yes? Okay, now this completes, sorry, here I have left 4, right? Now this completes what? 16th problem. Next we'll move for the 17th. 17th problem. Take the correct answer and justify. In triangle ABC, they have given some length of the 3 sides. We need to find the angle of, right? To find this, we'll use Pythagoras theorem and we'll check whether it will form a right angle triangle or not, right? So we'll take here longest side is AC, that is 12 centimeter, right? So we'll consider that as the hypotenuse. Now AC square is equals to BC square plus AB square. AC means 12 square, BC means 6 square, then AB means 6 square root 3 whole square will get 12 12s are 144 is equals to 6 6 are 36 plus 6 6 are 36 and this 3. 144 is equals to 36 plus 3 6 are 18, 9 and 10 will get. We'll add these two, will get something, it means 144 will get. Here we are getting LHS equals to RHS, right? So we'll write here LHS is equals to RHS. If LHS equals to RHS means obviously it is a it will be the right angle triangle or no? Yes, the Pythagoras theorem is stated for the right angle triangle only. Here we are getting LHS equals to RHS. So we can say that the angle at B, it is 90 degree. So the option is C here. This is the answer. This completes second chapter, that is triangles. Okay, thank you.